A single snowflake takes about 45 minutes to fall from cloud to ground. In that time, it makes roughly 3,000 individual decisions about its own geometry. Not metaphorically, literally. Each water molecule chooses where to attach based on quantum-level electric fields. And every single snowflake on Earth has made a completely unique set of those decisions. That's not poetry. That's physics. And it means if you were somehow shrunk down and trapped inside one as it formed, the universe would be building a prison around you one molecule at a time. Let's talk about what that prison would actually feel like. First, the scale. A typical snowflake is about 5 millimeters across. The water molecules building it are roughly 3 angstroms wide. That's 3/10 of a meter. To put that in human terms, if a single water molecule were the size of a marble, the finished snowflake would be roughly the size of a football stadium. You'd be somewhere in the middle of that stadium, watching the walls grow toward you at a speed you couldn't outrun. Here's what raises the stakes. Snowflakes don't just freeze randomly. They follow the most precise geometric rules in all of nature. Every snowflake grows with perfect six-fold symmetry, meaning 6 identical arms radiating outward from a central hexagonal core. That symmetry isn't imposed from outside. It emerges from the internal bond angles of water itself. The hydrogen-oxygen-hydrogen angle inside each water molecule is exactly 104.5 degrees. That one number, 104.5, is why every snowflake in history has had 6 sides. Change it by even 2 degrees and you'd get 4-sided ice. The universe could have been built differently. It wasn't. Now here's the first revelation that should genuinely disturb you. The 6 arms of a snowflake grow simultaneously, and they grow identically, even though they're not touching each other. Arm 1 has no direct contact with arm 4. Yet both arms sprout the same tiny side branches at the same moment, at the same angle. How? Because they're responding to the exact same microenvironment, temperature, humidity, pressure, at the exact same instant. The snowflake is essentially computing its own shape using the atmosphere as a shared instruction set. It's a distributed crystal computer running on thermodynamics. If you were inside it, you'd watch all 6 walls closing in on you at identical rates. No escape route would stay open longer than another. The geometry would be ruthlessly fair. If this kind of science makes your brain short-circuit in the best possible way, subscribe right now. We cover the physics that textbooks summarize in 3 sentences but that actually deserve 3 hours. Now, deeper layer. Let's talk about why you'd be crystallized alive and not just frozen. Freezing and crystallizing are not the same thing. When water freezes chaotically, think of slamming a water bottle into a freezer. The ice crystals are small, jagged, and random. That's actually what kills cells in frostbite. The tiny ice shards puncture cell membranes. But a snowflake doesn't freeze. It grows. Each molecule is placed deliberately by electromagnetic attraction into a hexagonal lattice. The process is called nucleation and it moves outward from a central seed, usually a dust particle or a pollen grain, at a rate of roughly 1 mm per minute in optimal cloud conditions. 1 mm per minute doesn't sound fast. But remember your scale. At molecular scale, that growth front is moving like a wall of dominoes falling toward you at genuinely terrifying speed. And here's the brutal part. As the lattice forms around you, it would release heat. Crystallization is exothermic. The very process of your prison being built would briefly warm the air around you. You'd feel a tiny pulse of warmth right before each new layer locked into place. Nature's version of a trapdoor clicking shut. The hexagonal lattice itself is also worth understanding because it's not just beautiful. It's structurally optimal. Hexagons are the most efficient shape for tiling a flat surface with minimal material. Bees figured this out. Ice figured it out independently roughly 4 billion years before bees existed. The lattice structure makes ice about 9% less dense than liquid water. That 9% density difference is why ice floats. And ice floating is why Earth has liquid oceans under polar ice caps. And liquid oceans under ice are why we think Europa, Jupiter's moon, might harbor life right now. 1 bond angle, 104.5 degrees. That's the thread connecting a snowflake forming around you to the possibility of alien biology. That's the implication. And it's enormous. We spend billions of dollars looking for life on other worlds. We point telescopes at distant moons. We debate the conditions necessary for biology to take hold. But the answer might live inside the geometry of a single water molecule. The same hexagonal physics that would crystallize you alive inside a cloud over Vermont is the same physics keeping oceans liquid under the ice of Europa. The same bond angle that makes snowflakes 6-sided instead of 4-sided or 8-sided might be the bond angle that makes complex life possible anywhere in the universe. You weren't just looking at a snowflake. You were looking at a universal template. And here's the question that should keep you awake. If the hydrogen bond angle were different, if evolution or physics had settled on a slightly different geometry, would the word life even exist? Would there be anything around to ask the question? The snowflake isn't just a pretty crystal. It's evidence that the universe was tuned, at the molecular level, for complexity to survive. One molecule, one angle, 104.5 degrees. Everything follows from that. If that idea just rewired something in your brain, you're in the right place. Subscribe and hit the bell. Next video, we go even smaller, and the physics gets even stranger.